Hello and welcome back to these videos on OCR A Level Chemistry. This is the 9th topic, halogens. Now, halogen is a name given to an element from group 7 on the periodic table. They are fluorine, chlorine, bromine, iodine and astatine. And we talk mainly about the three middle ones, chlorine, bromine and iodine. All halogens exist as diatomic molecules. So fluorine is F2, chlorine is Cl2, bromine Br2, iodine I2. And as you go down the group, they increase in boiling point. And they increase in boiling point because these molecules get more and more electrons, and so they get stronger and stronger induced dipole-dipole forces. The stronger the forces of attraction between the molecules, the higher the melting and boiling points are. So chlorine is a gas at room temperature and pressure, bromine is a liquid, and iodine is a solid. Each of these atoms has an S2p5 outer shell electron configuration, and they all tend to make 1- ions when they're reduced. For the halogens, reactivity decreases down the group. Fluorine is the most reactive of the halogen. And to explain that fully, I'm actually going to talk about something new called electron affinity, and that's described by this reaction. Now you should be able to see a similarity between this and ionization energy. With ionization energy, it's the energy required to remove an electron. Electron affinity is the energy released when a mole of gaseous atoms each gain an electron to form a mole of gaseous 1- ions. Now in terms of exam questions, these come up very rarely, and ionization energy questions come up all the time. But it's useful to be aware of electron affinities, and the things which affect electron affinities are the same things which affect ionization energy: the distance from the nucleus, the nuclear charge, and the shielding. And the reason why chlorine of these three is the most reactive is because the incoming electron, the electron that's being gained in an electron affinity, gets closer to the nucleus and it has less shielding the further up it is. The further down it is, the further from the nucleus that electron gets, and the more shielding it has. And so it's got less of a pull to go into an iodine atom than a chlorine atom, which is why chlorine is more reactive. Next up on the specification is a thing called a disproportionation reaction. Now, a disproportionation reaction is one where the same substance is both oxidized and reduced in the same reaction. And there's two specific disproportionation reactions that you need to be aware of. This is a reaction that happens when you put chlorine into water. It's used for water purification. And the chlorine here is an element, so it has an oxidation number of 0. The chlorine here has an oxidation number of -1, because it's with hydrogen, which has got an oxidation number of +1. The oxidation number of chlorine here is +1, because oxygen's is -2, hydrogen is +1, so you need +1 for chlorine to make it 0. So you can see between this chlorine and that chlorine, it's reduced, the oxidation number goes down by 1, and between the same chlorine but this one in the other chemical, the oxidation number increases by 1, so that's oxidized. The other disproportionation reaction on the specification is this one, which makes bleach. And you can see the same thing's happening. The chlorine's going from 0 to -1 in sodium chloride, and going from 0 to +1 in sodium chlorate 1. You also need to be aware of some uses for chlorine. Obviously, water purification is one of them. Chlorine's put into water in order to kill the bacteria that are present. And you need to be aware of the dangers of chlorine. So chlorine is a toxic gas, and so you need to put the right amount into water in order for it to kill bacteria but not be dangerous. Chlorine can also react with hydrocarbons to produce chlorinated hydrocarbons, which are dangerous. So the topic of putting chlorine into water to purify it is actually quite a contentious one, and you need to be able to weigh up the risks and the benefits of putting chlorine into water in order to determine whether it's a good idea or not. So it kills bacteria, but the ethical reasons of putting chlorine into water, but without that population have anything to say about it, those questions come up occasionally on exams. So be able to give a 1 or 2 mark answer about ethical reasons and weighing up the risks and benefits of putting chlorine into water. Now this last bit is about chemical tests. You need to be able to describe a chemical test which could be used to determine if there is a halide ion present. I'll say that again, a halide ion. This doesn't detect halogens, this detects halide ions. Now each of these ions in solution will react with aqueous silver 1+ ions to form a solid precipitate. And so when silver nitrate solution is mixed with a halide solution, then you get a precipitate of either silver chloride, silver bromide, or silver iodide. And you can tell which one you've got in two different ways. First of all, silver chloride is white, silver bromide is pale cream, and silver iodide is pale yellow. With experience, you can tell the difference between those colours, but without experience, they look quite similar. And if you want to be sure that you have silver bromide, not silver iodide, you have a second part to this test, and that is adding aqueous or concentrated ammonia. Because these three chemicals have different solubilities in ammonia. So silver chloride will dissolve in aqueous ammonia, silver bromide will dissolve in concentrated ammonia but not in aqueous ammonia, and silver iodide won't dissolve in any concentration of ammonia. And so, for instance, if you don't know if your chemical is yellow or cream, so you can't tell if it's iodide or bromide, if you add concentrated ammonia and it dissolves, that means it was silver bromide. If you add concentrated ammonia and it doesn't dissolve, then it's silver iodide. And this two-step test is used to determine whether you have chloride, bromide or iodide ions in your original solution. Okay, that's it for topic 9, which is the halogens. I hope you can join me for the next one. Goodbye.